channel. If you are new on this channel, do not forget to subscribe, like, comment and share. Today, we want to look at another aspect of organic chemistry, which is Iupac Nomenclature. This simply means the naming of an organic compound. So today I'll be showing you steps in naming organic compound. First step is that this is the pattern that the naming of an organic compound takes. We have the prefixes, the roots and the suffixes. So in the naming of an organic compound, you are going to see this pattern always being formed in the naming of an organic compound. So first thing, what is the suffixes? What is the prefixes? Prefixes means the substituent that is present in a certain organic compound. And when you come to roots, root is talking about the longest continuous carbon chain that is present in a particular organic compound. The longest continuous carbon chain is called the root. The suffixes is talking about the ending of the name of a particular family of an organic compound, and which we call the homologous series. So if you have an organic compound, that organic compound will belong to a certain homologous series. So that homologous series, the ending of the name of that homologous series is what we call the suffixes. Alright, now back to what we call our roots. If you look at this this number of carbon atom, I wrote from 1 to 10. So anytime we spot our organic compound, we are going to look at the number of continuous carbon chain that is present in that organic compound. If it's met, if it's 1, it will be called met. If it is 2, it's called et. If the longest continuous carbon chain that is present in an organic compound is 3, it's called pro. If it's 4, boot. 5, pent. 6, s. 7, 8, oct. 9, non. And 10 is what? Is dec. Alright, so this is constant. So if anytime you spot an organic compound, you are going to first look at the longest continuous carbon chain that is present in that organic compound, and that is going to help you to know what you are going to write for the roots. Alright, let's come to the table. I want to show you us a table, and that table is going to show us homologous series, the functional group, the prefix and the suffixes. Alright, so in this table we have what called homologous series, functional group, prefixes and suffixes. We need this table because this table will help us in the naming of our organic compound. So this side we have the homologous series. The homologous series simply means the family of an organic compound. Alright, so here I have the list of family of organic compound. Though it's more than this, but for this topic I want to talk about the common family that I'm going to deal with are listed in this table. Now when it comes to functional group, the functional group is talking about the group of atom or ions common to a particular homologous series, and they determine the chemical properties of that homologous series. So in a simpler manner, when you talk about functional group of an organic compound, we are talking about the means of identification of a particular homologous series. Now you want to know if an organic compound belongs to a particular homologous series. What you are going to look for is a functional group, because each homologous series, which means each family of organic compound, has its own peculiar functional group. It has its own means of identification. So anytime you look into an organic compound, what you are looking for here is you will be looking for the functional group. What is peculiar to that to that homologous series, that you will be able to know that a certain organic compound belongs to that family. Now, so let's quickly run through the homologous series and the functional group here. For alkane, the carbon will be joined with what? Single bond. So if you see an organic compound that the carbon is joined with single bond, and in that organic compound what we are seeing here is only carbon and hydrogen. It belongs to what? That organic compound belongs to this homologous series. It belongs to alkane. Then we come to this alkane, and alkyne. They are hydrocarbon. Now, yeah, they are hydrocarbon. That is an organic compound that contains only carbon and hydrogen. So that is what for these three homologous series. Now, when it comes to alkene, we are going to see carbon to carbon joined with what? Double bond. So if you see an hydrocarbon in which the carbon to carbon is joined with what? A double bond, that organic compound belongs to this homologous series, which is alkene. Now let's come to alkyne. For alkyne, if you have an hydrocarbon in which the carbon to carbon is joined with a triple bond, that organic compound belongs to this family called alkyne. So these three family 1, 2, 3, they are hydrocarbon, while the rest are not hydrocarbon. So for the rest of this family, they have their own specific what functional also. So if you look at the rest of this family, apart from these three families which are hydrocarbon, you see that in the functional group I wrote something that is constant to them. We have R. R is common to them. What is this R? Now this R that we are talking about is a symbol for a group called alkyl group. So we have what we call alkyl group. Some people call it alkyl group, whichever you want to call it. So for me, it's called what? Alkyl group. And this alkyl group is formed from this family called alkane. It's formed from what? Alkane. Now, how is this group formed? This group is formed when an alkane loses a proton. That means when alkane loses what? An hydrogen atom. For instance, let's take an alkane group which is called CH4. This is methane. We'll come back to that. This methane, and this is the molecular formula. If this methane loses one hydrogen now, it becomes CH3. It becomes this CH3. So it becomes this alkyl group. So it will be called methyl. Now we have another one, C2H6. This is a molecular formula for ethane. Let's say for instance, this ethane now loses one hydrogen. It will become C2H5. It has become an alkyl group and it will call ethyl. So you know that what is constant to this one is met. So and what ends the name of this group is YL. So just put YL because I said that this suffix for this what? For this group. So it is something that will be ending the what? The roots. This root is constant, but what will be ending this root depends on the suffixes of what? Of a group or an homologous series. So this now becomes methyl. So this C2, this CH3 becomes what? Met plus YL, which is the suffix for that group. It becomes methyl. Then this one becomes what? X, because it's, how many carbon is there? We have 2 carbon. So that is X. Then we are going to add the suffix of this group there, and that becomes what? Ethyl. So that's how we have our methyl, and our alkyl group is formed when an alkane member loses one hydrogen. So, and I said the symbol for this alkyl group is R. So what you are seeing here is an alkane that has lost one hydrogen. That is the meaning of this RR. It's an alkyl group. So it depends on the alkyl group that is present in that organic compound. So anytime you see R, we are talking about an alkyl group. Now before all other organic compounds, before all other homologous series are formed, apart from this hydrocarbon, they are formed when an alkane has lost one hydrogen. And when they have lost one hydrogen, the functional group of that homologous series will be attached to that what? To that alkyl group that remains. So the functional for Alkanes is now what? OH. Is the OH that replaces the hydrogen that was lost from that what? Alkane. And for alkalic acid is COH. So once we place the hydrogen that was lost from alkene is what? COOH. So that is what? That is the functional group for what? For alkanoic acid. For alkanol, the functional group is what? COR prime. For alkanoid, COOR prime. For alkana, CHO. For ether, OR. For amine, NH2. And for amine is CONH2. So when you spot this functional group in an organic compound, that organic compound belongs to this homologous series. And you know, this service is talking about the ending of the name of a particular homologous series. For alkene, what end is what? ANE. So for any organic compound that belongs to alkene, the suffix that will end in the naming of what? Of that organic compound is ANE. That's what will be added to the roots of that will be present in that organic compound. Now let's go back to how to now name our organic compound. Now let's come to the structure that we want to use for our naming of organic compound today. Now this is the first structure. Now if you look at this structure very well, we have carbon, hydrogen, then bromine, chlorine, iodine, then here we have CH3, that is methyl. That's methyl. Now this thing that we have our bromine, chlorine, iodine, and methyl, what's supposed to be there originally is hydrogen. So this hydrocarbon is what? I mean, this structure is what? Hydrocarbon. It was an organic compound that contains carbon and hydrogen. But what happened is that the hydrogen that was originally here was now replaced with bromine, chlorine, iodine, and what? And methyl group. And in the replacement of those hydrogen, that's what we call them what? Substituents. So all this one they are substituents because they substitute the original hydrogen that ought to be in this organic what? Compound. And I said that, don't forget, I said my substituent is my previous, because in the name of my organic compound is the what? Is my substituent that was what? The name of my substituent that will first appear, and that's what we call what? Previous. Alright, so now what we are going to do here is that we are going to number our substituents. We want to know the carbon that was our substituent what appears. You know, we said that our substituents has replaced hydrogen, so we want to look at which carbon do we have those what? Substituents. Now, and in doing that, you have to first what? Look at your root also. You have to also what? Look at our roots also. You have to determine our roots. Now, our root is the longest continuous carbon chain that is present in a particular organic compound. So let's look at some continuous carbon chain that is present in this what? Organic compound. I will now fish out the longest one. So we can have 1, 2, 3, 4, 5, 6. See, it is continuous. The carbon is joined with themselves on the what? On a continuous what? Form. You can also have 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. You see that those ones they also join with themselves what? In a continuous form. You can also have 1, 2, 3, 4. And you can also have 1, 2, 3, 4. Now they also join with themselves in a continuous form. So if you now look at the one that is longest and that is continuous is 1, 2, 3, 4, 5, 6. So our root here in this what? In this structure, our root is what? Is 6. Now after you have gotten your root, you now number your root to be able to know which carbon does your substituent what? Fall into. And in numbering of your roots, do not forget you are going to number this way and you are going to number this way. You number your longest continuous carbon chain, you are going to number it in this format and you are going to number it this way also. And after you have numbered, you now look at the lowest, the substituent that have the lowest numbering. So the substituent that have the lowest numbering is going to be the right numbering of your longest continuous chain. Now, so let's number the carbon that have the conjunction. We have 1, 2, 3, 4, 5, 6. And we can also number this way: 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Alright, so how do we know the what? The right numbering is after we have numbered like that, we now look at the number that have the number that shows the lowest substituent. The number that have what? The lowest what? substituent, the numbering that shows the lowest substituent is going to be the right numbering. So now let's look at it together. If you number this way, the bromine will be on carbon 3. Bromine will be on carbon 3. The iodine, which we will call iodine, will also be on carbon 3. For here, our chlorine will be on carbon 4, and our methyl will also be on carbon what? On carbon 4. Now let's come to this other one. If you number this way, our methyl will be on carbon 3. Methyl will be on carbon 3. Our chlorine will also be on carbon 3, and that will be chloro, because it's a substituent, it will be called chloro. And our bromine will be on carbon 4, bromo. And our iodine will also be on what? Carbon 4, that will be called iodine. So this is what you have. We have 3, 4, we have 3, 3, 4, 4 on this side, and we have 3, 3, 4, 4 here for this side also. Now, and our substituents will also be what? Arranged alphabetically. Another way is that what? Our substituent must be arranged what? Alphabetically. Alright, if you look at this numbering very well, we have number this side and this side. Now, if you look at this very well, they have the same number. We have 3, 3, 4, 4. This also is what? 3, 3, 4, 4. Now, I specifically pick this example so that I can pick out a point for you. Now, we number this way and we number this way, and they have the same numbering. Now, if you have the same numbering, the second rule that we are going to use to know the right one that have the lowest numbering, because if they have the different numbering, you can be able to pick out the one that have the lowest numbering. But now that you have the same numbering, how can you pick the lowest numbering? You will now use the rule of what? Alphabetical order. Because in our what? In our name of organic compound, we are going to consider the lowest numbering, and we are going to also consider the alphabetical arrangement. Now, in this substituent, the lowest alphabetical order is what? Is B, followed by C, followed by I, then followed by what? M. Alright, now, so the first numbering what? The first alphabetical order is what? B. So we are going to look at B. The B here is what? Is 3 bromo, and look at the B here is what? 4 bromo. So because of that, the bromo here is 4 and the bromo here is what? Is 3. Because of that, the right number will go for what? We go for this one. Because for my B, which is lowest what? Alphabetical order, is carrying 3. And for my B here is carrying what? 4. So this one is what? Is going off. Because of my bromo here is 3 and my bromo here is 4, and that is the first alphabetical order that we are going to write when we want to name our organic compound. So now we are picking this one as the lowest number because of my what? B here is my bromo, is my what? The lowest alphabetical order is carrying 3, and here is carrying what? Is carrying 4. So we pick this one as our right what? Right number. Because of that, now let's now name our organic compound. Let's name our organic compound. So here we have 3 bromo, 4 chloro, 3 iodo, 4 methyl. So let me write here, we have 3 bromo, 4 chloro, 3 iodo, 4 methyl. So we are finished arranging our prefixes. The next thing is our root according to our pattern of naming, and our root is 6. If you look at 6, what is our root for 6? That is x. So we have x. Now, our suffix is coming from the ending of the name of our homologous cis. So the homologous cis of this organic compound is alkane, because this is an hydrocarbon, and the carbon is joined with itself with what? With a single bond. So it's alkane, and the suffix for alkane is ane. So we add our suffix ane. So the correct naming of this organic compound is 3 bromo, 4 chloro, 3 iodo, 4 methyl hexane. Now let's look at how to name this second structure. Now this second structure is also an hydrocarbon. Just that the alkyl here has been substituted by bromine, and the methyl here and the alkyl here has been substituted by what? By methyl group. Now note that apart from alkane, all other homologous series, if we want to give them naming, you have to look at the specific functional group that is present in that organic compound, and the functional group that is present here is what? Is double bond. Now that double bond is going to have more priority than the substituent. So if you want to number your longest constituent carbon chain, you number in such a way that your functional group is having the lowest numbering, not the substituent. Alright, it is only in alkane that we use our substituent to consider how we number our longest continuous carbon chain. But if it's for other homologous apart from alkane, all other homologous are going to number in such a way that the functional group has the lowest numbering. So the first thing is to get our roots and to number in such a way that our functional group is having the lowest numbering. So our longest continuous carbon chain here is 1, 2, 3, 4, 5, or 1, 2, 3, 4. So the longest is 1, 2, 3, 4, 5. So we now number in such a way that the functional group is having the lowest what? Numbering. Now let's look at this place. If you number this way 1, 2, 3, my carbon is what? My double bond will be on carbon number 3. But if I number this way 1, 2, my double bond will be on carbon number 2. So that means that my right number will be 1, 2, and not 1, 2, 3. So if I number like this 1, 2, 3, 4, 5. So now my methyl will be on carbon number 3 and my bromine will be on carbon number 4. So the next thing to consider is my alphabetical order. B must come before M. So my right number will now be 4 bromo, 3 methyl. My root here is what? Is 5, and that's what? That is pent. That is pent. And I'm going to show where my functional group is attached. You know, which carbon is it attached to in the what? In the structure. It's attached to what? Carbon number 2. That is pen-2. And the suffix of an alkene family is what? ENE. That is in. So my correct naming of this compound is 4 bromo, 3 methyl, pen-2 in. Let's come to the third structure. Now this one is also what? An hydrocarbon. Yeah, just that the alkyl here has been substituted by bromine and the alkyl here has been substituted by what? Methyl group. But which type of hydrocarbon? The carbon to carbon here is what? Joined by what? Triple bond. That triple bond is what? Is a functional group of alkyne family. So this is an alkyne what? Structure. It's an alkyne structure. And I said that we are going to get our roots and we number in such a way that our functional group is having the lowest what? Numbering. So let's get our roots for this what? For this structure. We can have our longest continuous carbon chain can be 1, 2, 3, 4, 5, 6. It can also be 1, 2, 3, 4. So the longest one is 6. Alright, so now this one that I have the longest carbon chain, which is 1, 2, 3, 4, 5, 6. We can number this way and we can number this way. So if you number this way 1, 2, 3, my triple bond is joined to what? Carbon 3. And if I number this way 1, 2, 3, my double bond is attached to what? Carbon 3 also. So it's 3, 3. So how do I now number? Let me number this way because my substituent is what? It's at this side than this side. So that will determine what? My numbering now. No, so let me number this way because my substituent falls to this side. Alright, so I have 1, 2, 3, 4, 5, 6. Alright. And I'm going to consider alphabetical order also. B starts before what? Before M. And also another thing you have to consider is that you can have more than, your substituent can appear more than once in your what, in your structure. And if you have a particular substituent that is appearing more than one in your organic compound, you are going to introduce the place like di, tri, and tetra. More than once in this organic structure, so you are going to and how many does it appear? Two times. So you are going to introduce what, the previous what, di. So now on carbon number 2, we have one bromine here, and another carbon 2, we have what, bromine again. So we have 2, 2, because on this carbon number 2 we have 2 bromine. We have 2 dibromo. 2 dibromo, comma. Then on carbon number 3 we have what, methyl. We have 3 methyl. Now, and my functional group is attached to carbon number 3. My root is what? Is X. 1, 2, 3, 4, 5, 6. Is X. X. Then I'm going to show where my functional group is attached. It's attached to what? Carbon number 3. S, 3, I. So the correct naming of this what, structure is what? 2 dibromo, 3 methyl, S3 high. Now let's continue with number 4. This structure 4, and this place we have this structure, and don't forget the double bond is available here. This is also an hydrocarbon, and this carbon is joined by what? By double bond. Now this arrangement of this structure, if you look at it, is arranged in a pattern. It's not arranged like the one that we have been seeing. No, for all this one, they are arranged in what? In a straight or in a what? A branch form. But this one is arranged. This structure is what? Is structured in a peculiar manner. Now, and the peculiarity is that if you look at this place, it's as if the hydrogen here and the hydrogen here, they are what? They are side by side. And the group here also, they are side by side, and they are the same thing. So we have this side, we have the same group of atoms arranged side by side, and we have the same atom here, hydrogen, and it was side by side. Now, if you have side by side arrangement of some atom or group of atom, what we call it a cis arrangement. That cis is what? CIS. Yeah, it means side by side in what? In Latin word. It's a Latin word, and it means side by side. So in this arrangement, this I show that this compound is what? Is an alkene family because of the double bond that is between carbon to carbon. And we can count the continuous carbon chain that is present in this what? Organic compound. There's one carbon here. This 1, 2, 3, 4. And you see that they are doing what? To one another in a continuous what? Form. We can write this one this way. We want to see very well, so that we'll be able to see how they are joined in what? A continuous form. Let me draw it this way so that you can see what the way so you see that the carbon is continuous. 1, 2, 3, 4. And if you do that also 1, 2, 3, 4. So the double bond is between what? Carbon 2. So here now this CH6 is arranged side by side, and hydrogen is arranged side by side. If you see this kind of arrangement, call this cis arrangement. So we have cis. Then is what? The longest carbon chain is 1, 2, 3, 4. That is 1, 2, 3, 4. That is both. And the final group is attached to carbon number 2. Both 2 in. That is 6 both 2 in. If you number this one also 1, 2 is what? It's also what? 2. And remember this way 1, 2 is what? The double is attached what? Carbon number 2. So the same thing here, but what we are going to see here is that it's still the same structure here, but what we are going to see as different is that the hydrogen is arranged alternately, and the methyl group is also arranged alternately. So we have the same group arranged what? In alternate manner. In Latin word, that is called trans. It's called trans. So and it's still what? We count the number of carbon here. Longest consecutive carbon chain 1, 2, 3, 4. They are joined with themselves in a continuous what? In a continuous form. So it's still good 2 in, but it's what? It's with trans because the atoms are arranged what? Alternately. They are arranged what? In alternate form. Yeah. The atoms are arranged what? Alternate form. So when you see an atom arranged in alternate form, what? To each other or to one another is what? You are arranging in what? In trans what? Form. And you're going to count the number of continuous carbon chain there is 1, 2, 3, 4. And the functional group, which is what? Alkene, is attached to what? Carbon number 2. You count for this one 1, 2. You count for this one 1, 2. That is trans both 2 in. So that is the name of that what? Of that structure. Let's come to this structure. If you look at this structure is what? If you want to look at the functional group there, the functional group here is what? Is OH. So you know that I said that every other organic compound apart from alkane, they are going to be derived when an alkane loses an hydrogen atom, and that becomes what? Hard. The remaining thing will be what? Hard. And it's the loss of that atom that will now lead to attachment of a particular functional group. So here, what's supposed to be here is hydrogen, but what is replacing it now is what? OH. That OH is a functional group that is peculiar to Alkanes. So that means that this organic compound, this structure is what? Is an Alkane. So the next thing is to find the root of this what? Of this structure, and the root is 1, 2, 3, 4, 5. That is the only thing that we have there. So the root is what? Is 5. So do we have any prefixes? No. We only have the functional group in this what? In this organic compound, and that is OH. And we are going to tell us where what that OH is what? In the structure. So if we number this way 1, 2, 3 is on carbon number 3. If you only number this way 1, 2, 3. So not on what? On carbon number 3. So we can number anyway, just to locate where the OH is what? Is on what? On the is on the what? Is on the structure. Where we can find the OH in what? In the structure. Now that is what? That is on carbon number 3. So the name of this, there's no previous. So we start from the root, and the root is what? Is pen. So we have pen. And another thing that I want to note here is that for this alkane, I say that it is when an alkene has lost one hydrogen that leads to the attachment of other functional group that leads to formation of other organic compound. So in this name of this organic compound, this pentane, it should be pentane, normal for normal alkene, but because the hydrogen here has been substituted by alkane, so what happens is that the heat in the pentane is going to be removed, and we are going to add the surface of that functional group here, which is what? Alkane, and that is OL. We add our OL here. So to form an alkane, we are going to remove the heat in the alkane and replace it with what? All family of the alkane. But we are going to tell us where the all family is in what? Is in that alkane. That is what? On carbon number 3, and that's why it's what? Penta 3 or. Let's come to the structure 7. For this structure 7, what's supposed to be here is H, but it has been replaced with what? COOH. So the H that has gone, the remaining thing, I said when an alkene loses one hydrogen, it becomes what? What remains is what? R. So now, what is now joining? The hydrogen that has been lost is now COOH. Now that's R, that's COOH. This COOH is the functional group of what? Alkanoic acid. So let's count the longest continuous carbon chain. We have 1, 2, 3, 4, 5. That is what? That is pent. Alright, and we say that this is formed by The E in an alkane will be lost. So it's normally, if it's H that is here, it should be pentane. So we remove the E and we add the suffix of that what, of that functional group that is attached to that H that was, when that H was lost. The functional group that replaces it, we go and look at the what, the suffix of that what, of that family. And that family, this family is what, alkanoic acid, and the suffix is what, oic acid. So this now becomes pentanoic acid, because the E in the alkane will be removed and the suffix of that family will be added to it. We have what, pentanoic acid. And note that this functional group is always at the terminal end of the what, of the organic compound. If it's not at the terminal end, then this COH will not serve as functional group, it will serve as what, as substituent. But if the COH will serve as a functional group, it must always be at the terminal end of the organic what, compound. So the name of this compound is what, pentanoic acid. So for this section, we'll be stopping at the name of what, alkanoic acid. And this is the first part of this name of organic what, compound. Now the next class, I'm going to continue with the naming of other organic compound and other homologous what, series, and that will be in part 2 of this naming of organic compound. I want to watch out for that part 2, because that's where I will talk about naming of all other homologous what, homologous series. I believe you have enjoyed this section that we did today, and if you have actually really enjoyed, do not forget to subscribe to this YouTube channel, like this video, share it with your friend, and anticipate for the other video that will be uploaded on this channel.